The divergence of a vector field F equals F sub x, F sub y, F sub z measures how much the field spreads out or converges from a point, just like the net amount of water flowing out of a tiny balloon placed at that point. In Cartesian coordinates, the formula is del dot F equals partial of F sub x with respect to x plus partial of F sub y with respect to y plus partial of F sub z with respect to z. Each term is a partial derivative that tells how fast the component of the field changes in its own direction. If the sum is positive, more stuff leaves the region, a source. If negative, more enters, a sink. The operator del dot is called the divergence operator, and the result is a scalar, a single number at each point. Imagine a fluid flowing through a pipe network. At a junction where water is injected, the fluid density inside a small sphere around the junction increases. The sphere acts like a source. Conversely, a drain that removes fluid acts like a sink. The divergence at a point tells you the density of sources minus sinks per unit volume. In engineering, a positive divergence in a velocity field indicates compressibility or a blowing out region, while zero divergence means the fluid is incompressible, no net volume change. The divergence Gauss theorem links the volume integral of divergence to the flux through the closed surface that bounds the volume. Triple integral over v of open parenthesis nabla dot f close parenthesis dv equals double integral over s of f dot n hat ds. In exam problems, you often identify the volume v, for example a sphere, a cube, or a cylinder. Compute nabla dot f, a simple scalar, and integrate over v using symmetry or standard volume formulas. Or if the surface integral is easier, directly evaluate f dot n hat on each face of S. Typical exam trick: choose the easier side of the equation. For a radially symmetric field F equals k r r hat inside a sphere, the volume integral reduces to 3k times the volume, while the surface integral is just k r cubed times 4 pi. Both give the same answer, confirming the work. Definition: the curl of a vector field F equals open parenthesis F sub x, F sub y, F sub z close parenthesis measures how much the field tends to rotate or swirl around a point, similar to the tiny paddle wheel you might place in a flowing fluid. In Cartesian coordinates, the curl is a vector given by del cross F equals a column vector with three components: partial derivative of F sub z with respect to y minus partial derivative of F sub y with respect to z. Second component, partial derivative of F sub x with respect to z minus partial derivative of F sub z with respect to x. Third component, partial derivative of F sub y with respect to x minus partial derivative of F sub x with respect to y. Each component tells the rotation about the respective axis. The operator del cross is called the curl operator, and the result is another vector field. A simple way to remember the pattern is the right-hand rule determinant form. Del cross F equals the determinant of a 3x3 matrix with first row I hat, j hat, k hat. Second row partial with respect to x, partial with respect to y, partial with respect to z. Third row f sub x, f sub y, f sub z. Place a tiny paddle wheel in a flowing fluid. If the wheel starts to spin, the fluid has local rotation. The axis of spin and its speed are given by the curl vector at that point. The direction of the curl tells the spin axis, right-hand rule, while its magnitude tells how fast the wheel would spin per unit area. In airflow over a wing, regions of high curl correspond to vortices, the smoke rings you see behind a helicopter blade. In electromagnetics, a non-zero curl of the electric field indicates a changing magnetic field, Faraday's law. Vortex lines are curves that are everywhere tangent to the curl vector, just as magnetic field lines are tangent to the magnetic field. Explanation: Stokes prime theorem converts a surface integral of curl into a line integral around the boundary curve. Double integral over S of nabla cross F dot n hat ds equals line integral over C of F dot dr. In exams, you typically 1. Identify the surface S, often a simple flat region like a triangle, rectangle, or part of a sphere, and its boundary C. 2. Either compute the left side by finding nabla cross F and integrating over S, or compute the right side by parameterizing C and evaluating the line integral. A common shortcut: if the surface is flat, and the curl is constant, the left side becomes curl.area vector. For example, for f equals negative y, x, 0 and s a unit square in the xy plane, nabla cross f equals 0, 0, 2 and the surface integral is 2 times area equals 2. The line integral around the square gives the same result, confirming the theorem. The theorem is especially useful when the boundary curve is simple, but the surface is complicated or vice versa. Compute the partial derivatives. Partial f sub x with respect to x equals partial of 2xy with respect to x equals 2y. Partial f sub y with respect to y equals partial of x squared with respect to y equals 0. Partial f sub z with respect to z equals partial of z cubed with respect to z equals 3z squared. Add them. Divergence of f equals 2y plus 0 plus 3z squared equals 2y plus 3z squared. So at the point 1, 2, 1 the divergence is 2 times 2 plus 3 times 1 squared equals 7. This positive value tells us that around 1, 2, 1 the field behaves like a source. More stuff is leaving the tiny volume than entering. If you were asked to evaluate triple integral over v of divergence of f dv over a box, you would integrate 2y plus 3z squared over the limits of the box. This step-by-step process is exactly what examiners expect. Write down the formula, compute each derivative, and simplify. Explanation: take the same field f of x, y, z equals open parenthesis 2xy, x squared, z cubed close parenthesis, and find its curl. 1. Use the determinant or component formulas : subscript x of nabla cross f equals partial of f sub z with respect to y minus partial of f sub y with respect to z equals 0 minus 0 equals 0. Subscript y of nabla cross f equals partial of f sub x with respect to z minus partial of f sub z with respect to x equals 0 minus 0 equals 0. Subscript z of nabla cross f equals partial of f sub y with respect to x minus partial of f sub x with respect to y equals 2x minus 2x equals 0. 2. Therefore nabla cross f equals open parenthesis 0, 0, 0 close parenthesis. The curl vanishes everywhere, meaning the field is irrotational dash. A tiny paddle wheel placed anywhere would not spin. In fluid mechanics, this corresponds to a potential flow, and in electrostatics it corresponds to a conservative electric field. If the field had been G equals open parenthesis negative y, x, 0 close parenthesis, then nabla cross G equals open parenthesis 0, 0, 2 close parenthesis, indicating a constant rotation about the z-axis. The exam calculation follows the same pattern: write the 3 component formulas, substitute the given expressions, and combine like terms. Typical exam items. Multiple choice: which of the following statements about the vector field f equals the vector y negative x 0 is true? Option A, divergence of f equals 0. Option B, curl of f equals the vector 0, 0, 2. Option C, both A and B. Option D, neither. The correct answer is C, testing both divergence and curl formulas. Short answer: state the physical meaning of a positive divergence in a velocity field. Expected answer: it indicates a source, fluid is expanding or being injected at that point. Short calculation: given f equals the vector xz, yz, xy, compute the divergence of f and interpret the sign at the point 1, 1, negative 1. Students must differentiate, add, and comment on source or sink. Conceptual: explain why the line integral of a gradient field around a closed loop is 0. This checks understanding of the curl of the gradient of phi equals 0. These formats test definition recall, ability to apply formulas, and physical intuition. When preparing, practice each type. Memorize the formulas, do quick derivative checks, and link the results to real-world pictures of sources, sinks, vortices. Key identities that appear in almost every exam. 0. Divergence of a curl. Nabla cross bold A equals 0. No matter what vector field bold A you start with, taking its curl first and then its divergence always gives 0. This is a direct consequence of the mixed partial derivatives cancelling. 0. Curl of a gradient. Nabla cross nabla phi equals 0. A scalar potential phi produces a conservative field, there is no rotation. Product rules. Nabla dot phi bold A equals phi times nabla dot bold A plus bold A dot nabla phi. Nabla cross phi bold A equals phi times nabla cross bold A plus nabla phi cross bold A. Vector Laplacian. Nabla squared bold A equals nabla of nabla dot bold A minus nabla cross bold A. These identities are used to simplify expressions in electromagnetics, fluid mechanics, and elasticity problems. Knowing them by heart saves time and helps you spot tricks in exam questions, such as recognizing a term that must be zero without full calculation.